Welcome students who want to look at business math and statistics, and we're going to start with statistics specifically. Now, when we talk about statistics, this is a branch of mathematics. We want to talk, it's a branch of mathematics. Statistics is a branch of mathematics, and it is concerned with, so what is it concerned with? I'm going to abbreviate it here. It is concerned with the aspect of collection. We need to do collection. It is concerned with the aspect of organizing. Don't mind about S and Z. It is concerned with the aspect of interpretation. It is concerned with the aspect of presentation, and finally, presentation. Then finally, it is also concerned with the aspect of analysis. Now, analysis of what? It is analysis of numerical data. Numerical data. Now, some of the things I may not write it down. Numerical data refers to that information in form of figures. Like when we are counting, take an example of when we talk about 1, 2, 3, and so on. Those are numerical information which can be put in numbers, and this is what we refer to as statistics. Now, we may have to look at the importance of statistics. We may need to look at the importance of stat. I'm abbreviating this to mean statistics. Majorly, we're going to look at three importances or uses of statistics in real life. One, it is used to organize numerical data. To organize, as just I will take here, organize. If I'm to look from this word, organizing numerical data. Now, we may have information, very many figures, 1, 2, 3, 4, just like our examples, but they may not be organized. So using statistics, we can be in a position to organize this information in terms of tables. We can be in a position to organize this one in terms of tables. That's why we shall look at tables. We can be in position to organize it in terms of graphs. We can be in position to organize it in terms of charts and so many others. But we are looking at the first importance or reason of statistics as being organizing numerical data. To give it more meaning, not everyone can understand, but when you express it in terms of charts, pie charts, graphs, tables, one is in a position to understand information or statistics all very well. The second reason or importance of statistics, to understand statistical techniques underlying decisions that affect our lives or well-being. This one I may not have to explain much, but the most important, the issue is to understand. And we are saying understand statistical techniques underlying decisions that affect our daily life. What could an example be? How can we understand? They may show you the population. The size of the population is an example of statistical data. So you're in a position to know, maybe they have expressed it in terms of percentage. You know that how in Uganda, maybe this tribe, I would use an example of the Baganda. It is around approximately 18 point something percent, and you round off maybe to 19%. This would mean, if they tell you that Baganda as a tribe occupies 19% of the Ugandan population, it means there are 19 people out of every 100 Ugandans. So that makes you to understand the statistical techniques underlying decisions that affect our daily lives or well-being. Then we look at the third aspect or the importance of statistics, to make informed decisions based on the information generated from the processed data. Informed decisions. decisions. Now, when we talk about informed decisions, whenever we make a decision, it should be supported based on facts. We don't use always our intuition or our understanding. That one could be biased based on culture or what. But if we say in Uganda, right now the COVID cases are increasing. How are they increasing? You need to show the figures. And from that, we had mentioned the third importance of statistics as being to make informed decision basing on information generated from processed data. So if you have your statistics from the population, maybe about COVID, how many members, then you know how many drugs to purchase. That is how we say you make informed decision. Now let's define the term data. Now when we talk, we are going to use the word data several times. This is any information that is collected. I'm using the word information, though we shall also look at it, but any information that is collected. Data is any information that is collected. And now, let's look at the practical application of statistics. Practical applications of stat. I'm sorry for the abbreviation. So when we look at practical applications of statistics, statistics is applied in very many fields. Actually, in each and every aspect of life, we shall see fields like industry. Talk about, of course, we shall look at it, how does industry use statistics. We shall look at fields like commerce and trade, physics, mention all the other subjects. And once this information is gathered in terms of statistics, of course, we give it some type of interpretation. Now, once we give it some interpretation, this interpretation could be in terms of, in economics, we talk about per capita. Per capita. If this is the income received by an individual in the whole country, and we get it by looking at the gross domestic product of a country versus its population. It's an average measurement. So the interpretation, you know, what is the average income received by each and every citizen? We talk about unemployment. You need to know how many people are employed and those who are maybe employed. So we talk about unemployment. This information can be applied to know the unemployment levels in a country. We talk about population growth rate. Population growth rate. So all this, it shows us really how statistics is very important and applied in daily life in different fields. We need to know what is the average income of every citizen in the country, how many citizens are employed, what is the rate of population growth rate. All this is very necessary regarding statistics. Now, we want to look at some commonly used information. We can talk about raw data. Raw data. Now, when we talk about raw data, we are simply meaning that data which is not organized numerically. Not organized. Information that is not organized. If you find I have the marks for the students, I've scored, this one has got 25, this one has got 80, it's mixed up without any kind of arrangement, we call it raw data. Immediately after looking at raw data, I want to talk about discrete. Discrete data or discrete raw data, whatever you prefer. But discrete data, when we're talking about discrete data, here majorly we are concerned about data that takes only exact value, that takes only exact values. Now we shall use more of examples to understand what is discrete data. For example, we may talk about it takes 1, it takes 2, it takes 20, it takes 33, and so on. And what are these? We are saying that takes only integral values. For example, number of students in class. You can't say 3.5 students. You have to say there are 4, there are 3. Human beings are not counted. They are counted as whole numbers. That is an example of discrete data. Talk about the maybe if you want to talk about number of students in class, number of cars passing a certain street, number of books in the library, you cannot mention them 3.5, 3 point what. So that is what we refer to as discrete data. Now, immediately we talk about another one which we call continuous data. Now, I'm not giving the real definition, but I want you to understand. Now, when we talk about continuous data, this is data that cannot take exact values. I'm using the opposite, that cannot take exact values. That cannot take exact values. Now, what do we mean when we say cannot take exact values? Now, we shall talk about continuous data can therefore take any value. This means it can take any value. Now, what do we mean when we say it can take any value? We talk about, for example, we can be in position to talk about the heights of students in class. We cannot say maybe height is measured using meters or centimeters. You may find somebody is some centimeters with some other measurement like a millimeter. So all those decimal points can be covered under continuous data. We talk about time measurements, like when you are talking about what is the time right now, you can't say we are measuring time in terms of hours only. You need to consider likewise minutes. Sometimes you need to consider also the seconds. We may also need to consider as well. Okay, students, now let's look at what we call a variable. Now, when we talk about a variable, is a quantity which is counted or measured. Actually, most of the things we use in statistics, especially if it's an individual item, we call it a variable. It could be a variable X, a variable Y, A, B, C. So any quantity which is counted or measured is a variable. And that is what I can simply talk about a variable. Now let's look at representation. We talk about ungrouped data. We talk about ungrouped data. Ungrouped data is almost the same as raw data. Close. It may not mean exactly the same, but it is closely related. So when we talk about ungrouped data, is information which is not organized also in any form. That's why we say it is close to raw data. And specifically, I want to look at representation of ungrouped data using frequency tables. Representation of ungrouped data using frequency tables. This is core, considering what we're going to look at. This is very core to what we are going to look at. Representation of ungrouped data using frequency tables. Now we're saying by counting, now to get the frequency, we shall always have a lot of information. But when we're talking about when we count, by counting the number of times each value occurs and forming a frequency distribution table is our concern here. If they have given you information 1, 2, 1, 3, 4, 6, 1, 2, 3. Now we shall be in a position to look that some numbers are repeating themselves. Look at 1, 1, 1. Look at 2, 2, 3. So when we come to the issue of frequency, once to avoid the issue of repetition, we're saying by counting the number of times each value, like let us see, that is the one where we're talking about representation of ungrouped data using frequency table, so that we avoid the repetition and we try to summarize them. Now, what is frequency? When we talk about frequency, so regarding frequency, we are simply saying it refers to the number of times an item occurs. Here we are talking about the number of times an item occurs. So frequency simply means, if we are looking using our example, how many times does the 2 occur? We have a 2 here, we have a 2 here. So it occurs 2 times. So the frequency for a 2 is 2. What about 1? What is the frequency for 1? The number of times 1 occurs in the data. 1, 2, 3. So this is what we refer to as frequency, the number of times an item occurs. And we're saying in most cases, an item occurs more than once. As you can see, most of the information we are going to get, an item occurs more than once. You see 3 occurring more than once. See 1 occurring more than once, 2 occurring. So this, you should take notice of that one. We're saying frequency distribution tables is used to remove repetitions. You know, when a table helps us to summarize, as we're going to see. And we're saying the frequency is easily obtained by using what we call tallying. We are going to do tallying. Tallying is simply coming up with bundles. If you have ever met it, something where 5 you represent, this is what we call tallying. It's what is going to help us. And we have to look at our example. Let's look at our first example. Now, how is this example going to be? I'm going to read, since I will be in a position to give you the notes. But we are saying the following data gives the number of blind students. So we want to look at the number of blind students in 10 randomly chosen classes in a certain university. Now, what is, we are concerned about blind students. And we're saying the following data gives the number of blind students in 10 randomly chosen classes. Number of classes. So classes, we are saying there are 10 classes. We are also going ahead to say in a certain university. And what are these now, the number of students they are giving us? They are giving us 0 in one class. They are giving us 2. They are giving us 1. They are giving us 4. Remember, these are separate. They are giving us 2. They are giving us 3. They are giving us 2, 3, then 2 again. They are giving us 1, they are giving us 5 and 4. I first count to be sure that my example is right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 classes in a given university. So given such information, they have given us that the following data gives the number of blind students in 10 randomly chosen classes in a certain university from the frequency distribution. So form a frequency distribution table. So they are asking us to form. We should form a frequency distribution table. This is the question. Now, how are we going to handle this? By looking at this information to come up, we're going to say our solution should have the number of students. I'm sorry, I'm leaving it in brief. We're going to look at our tally, which I said is very important. Then we shall have to look at the frequency. Now, by looking at this, we shall not want to repeat. We have a 0 here. Put it there. We have a 1. We are trying to be orderly. We have a 2. We have a 3. We have a 4. We have a 5. Is there any other figure I don't want to repeat? How many times does 0 appear? It appears here. You cancel and you put your tally here. There is a 2. You go to the line of 2. Put there. There is a 1. You go to the line of 1. Put there. There is a 4, go to the line of 4, put here. There is a 2, again repeating, come to put a second one. There is a 3, come to a 3, it had not yet got. There is a 2 again, come to the line of 2, put another one. There is a 1, go to the 1 and add another one. There is a 4, go to the line of 4, add another one. There is a 5, appearing once, and put it here. Now, having got this is our tally. As you can see, 2, 0. Oh, how did I put? It was one which repeated, and I made a mistake here. Sorry for this. So, for 0, it appears once. It is 1 that is appearing twice. So now, for this one, 0, we put, there was one class without a blind student. They were, for those ones, they were regarding 2, then 2, this is 3, this is 3, there is 1, 4, there is 2, and 5, there is 1. Then we sum them up. This is summation of frequency. Then we're in a position to look when we add up 1 plus 2 plus, this is 3, 4, 7, 9, 10. And this shows us the total number of students. We have just done what we call the distribution table. And it has showed us very well how we can represent any raw data into a distribution table. Okay, students, let's still looking at the frequency distribution table. Let's look at example 2. And under our example 2, we are looking at, we are saying, the example is saying the following temperatures. As you can see, these are temperatures in degrees centigrade. The following temperatures were recorded over a 20-day, over a 20-day period in January, Jan 2021. So every day they would take some measurements, as you can see. The first day it was 23 degrees, the second day 19 degrees, the third day, and likewise until after all the 20 days in January were taken. And given this information, of course, they are asking us, though it's not written, but we can use from the example we are yet to see, form a frequency distribution table. So this is raw data, and we want to group it in some orderly way. Now, the most important thing, whenever they say randomly, the word randomly, simply means without basing on any order, without order of selection. Random simply means without order of selection. Anyone can be picked. It's like a gambling game. Anyone can win. It doesn't need a bright person. It doesn't. So when we say randomly, it doesn't mean there was any order of consideration. So how do we do this? The most important here, we first identify, look at the figures, look at the lowest value and the highest value. Because we want to organize, you can see temperatures. So if you see from this 23, 19, 15, you pay attention, you will discover that 15 is the lowest. That's why I have started with it. And you go on recording which one is the highest. Of course, others are repeating themselves. We don't need to write it when we're looking at the temperatures. The temperatures actually, if you see from here, they were only 1, 2, 3, 4, 5, 6, 7, 8. They were only from 15 to 25. Other days were just falling in between. So now we make a tally. We start 23, the first day 23, we come and tally under 23, put a tally. Put a tally 1, and you've cancelled. 19, come to 19, put a tally. I can use a different pen if this one is becoming. So we are saying put a tally. Then come to 15. Go to 15, where does it fall? Put a tally. Go to 18, put a tally. Go to 20, put a tally. Go to 18 again, put another tally. Go to 21, put a tally. Go to 18, put a tally. Go to 20, put a tally. Go to 21, put a tally. Go to 20, put a tally. got 22, put a tally, got 20, tally, got 20. Now, whenever you have made, of course, 4 of them, we make a bundle, the 5th one crosses it. Then 15, put a tally, 25, put a tally, 20, put a tally, 21, put a tally, 18, put a tally, then we end up with the 22, we put a tally. Now, having looked at this information, after having, this was a line to show where our tally passes. Now we go to the frequency. Frequency, you just count how many were they repeating themselves. From the frequency here it was 2, from the frequency here it was 4, here it was 1, here it was 6, here it was 3, here it was 2, here it is 1, and here it is 1. So we come up, we sum them up, summation of frequency. Then we see we're in a position to count and come up and see whether we are right. 1, 2, 4, 7, 13, 14. This makes it 18, 20. So we can see that of the 20 days in the month, this is how the frequency distribution table comes up. And now here we have an exercise for you. We have done already 2 examples. So the following data shows the number of children in 30 randomly chosen families in Kampala. And these were the number. According to the parents, one family had 1 child, another one had 2, another one had 4, another one did not have. So you look at it, and you're in a position to look at the lowest, and you form a frequency distribution table. This is your do it, and we can be in a position to check from our notes whether we are right or wrong. Okay, my students, let's look at now grouped data. When we talk about grouped data, we want to talk about this is data that has been organized into groups known as classes. So we are saying grouped data is data organized into groups, which are known as classes. And we're saying grouped data is one that is classified, which is given some kind of classification. And we're saying a class is a group of data which is related in some way or by some user-defined property. For example, we are saying if you look at the age of somebody, age can be grouped accordingly. You can consider those ones who are in their teens, like in 10, we say 11, 12, those are in, we talk about 12, 13, those are in their teens. Those ones in their 20s, those ones in their 30s, those ones are in their 40s. So that is a kind of classification, what we call a class. Those ones who are from 30 to 39, we put them alone. Those ones who are from 0 to 9, those ones from 10 to 19, those are the kind of classes we have. And we are giving an emphasis that each class is of a certain width. And we are yet to define what is a class width. And we are saying known as a class width. And a class width is the same as a class interval, is the same as a class size. And the class interval, we are simply saying, is important when it comes to drawing the histogram and the frequency diagrams, as we are yet to see in the nearby future. And we're saying classes can be of the same size or different sizes. And we are saying we have our examples that we're going to look at. We're saying the class interval is always a whole number. I want you to take this. Even if you get with a decimal, but you have to round it off to the nearest whole number. So what you need to take note, a class interval, a class width, or a class size is always a whole number. It can be 5, 10, 2, 3, but as long as it's a whole number. Then we look at examples of grouped data where the classes have the same class interval. Let us look at the ages when we are grouping. Those ones who are from 0 to 9, they are 12 in class. So when you see here, the whole class interval is the same. There is no diversion. It is just the gap of the same class intervals. We're going to see how to get the class interval. Then we look at another example where the class interval is different with the different class intervals. We look at from 0 to 9. We are looking at, so as we are trying to look at this second example, we are looking, this is supposed to be the class interval, not the frequency. Sorry for this. This is the class interval. This is class interval. So we are looking at the class interval here is 10. The class interval here is 10. The class interval 20 to 29 is 10. But here, 30 to 49, the class interval is 20. Here, 50 to 79, the class interval is 30. So these are good examples to illustrate how the class interval can be illustrated. And then we can see how we can proceed, and we look at possibly the general rules for grouping data. So students, let's look at the general rules for grouping data. There are basically two rules to be followed. One, we shall need to calculating the class interval. You remember we have seen the class interval. So how are we going to calculate the class interval? There are two steps involved. A, determine how many classes you want. This is a choice by a student. You need to have a total classes, of course, as we've seen. If you are looking at age from 0 to 9, one class, 10 to 19, second class, 20 to 29, third class. How many classes? Do you need 5? Do you need 10 classes? Do you need 6 classes? That is what we're saying. Determine how many classes you want, depending on how you're going, how many is your preference. Then B, subtract the lowest value from the highest value in the data set and then divide by the number of classes you want. How are we doing it? Class interval is given by the highest value. Look at this information. First jump to this information. If we're given such information, we shall have to go and look at all the information and try to find out what is the highest value. If I'm to you pay attention to this information here, you may discover that all this, what is the highest and what is the lowest value. I can put like 38 is the highest value. What is my lowest value? By looking at this, you look at this column, you look at this third column, look at this fourth column, you look at the next one, you pay attention. Which one is the lowest? They are all 2-digit figures, and we have already discovered 38 is the highest. Which one is the lowest? By paying particular attention to each column. We have 11 here. Proceed and see, we have 12 in this one as the lowest. In this one we have the lowest being something, I think 15. This one, you look at this one, what is the lowest? We have 14. This one, the lowest being 12. Is there anything below 11? Continue, proceed, look at this one, the highest. We will want to look at anything below. Keep on checking. So what is the lowest figure? We have a 10 here. So 10 is the lowest. So would you say the highest in this situation would have been 38, the lowest being 10? Then how many classes do we need? If you need 10, if you need 5, so we shall do 38 minus 10, which is 28, divided by the number of classes. This is how we calculate the class interval or determine the class interval we're going to use. Remember, the class interval we saw like from 0 to 9. So our class interval here is what we are trying to look from here to here. So this could be 10. We want to determine the number of classes that we shall have. So the class interval is given by the highest minus the lowest divided by the number of classes you want to have. We look at step 2 of the general rules for grouping data. Finding the class frequency. What is the class frequency? If you are saying from 0 to 9, how many members, how many students fall under this class? Let us say they could be maybe 3. So that is the frequency through tallying. So that is what we're saying. And we're saying under the frequency distribution, the number of observations falling into each class interval is known as frequency. And it is best determined by using tallies. You remember we did this, what we are tallying, a bundle and the rest. This is what we call tallying. It helps you to determine the frequency. And we are saying, let's look at example 3. The following table shows the data on length of time in minutes. It took 80 students in senior 3 math class to complete a certain exercise. And we are seeing the minutes. Remember, all this is in minutes and is separate from each other. So one student took 23 minutes, another one 24, another one 18. We saw the lowest being 10 and the highest being 38. So you look at all this, and the question is asking, group the following raw data into 6 classes. So here they have given you the number of classes they want. The number of classes, they are saying we should group it into 6 classes. So if we were to come back to our determining the class interval, it would be 38 minus 10 divided by this one would have used the 6. And let us go and do this example. Of course, I'm going to leave it. I'm going to only rub the top part. Then we proceed and see how we can handle it. Okay, students, now let's look at this example. The following table shows the data on the length of time. Sorry for this. This is time. On the length of time in minutes, it took 80 students in A3 math class to complete a certain exercise. And we have these students. Let's look at our example 3. We said, as we had said, our example 3, we said the following table shows the data on length of time. This is time, on length of time in minutes. It took 80 students in a 3 math class to complete a certain exercise. And we have the time taken by each and every of the 80 students. And I had said earlier, whenever you have such raw data, you need to find out, go through and find out what is the highest. And in this situation, we said the highest is 38 and the lowest was 10. Any other figure, of course, there are 2-digit figures. The highest is 38, the lowest. So, and we want to determine the class interval. We want to determine the class interval. So the class interval said is given by the highest value minus lowest value divided by, in this question they said group the following raw data into 6 classes, meaning the number of classes here, number of classes you want. In this situation, it's not what you want, but it's what you are given. So highest 38, I'm substituting the highest value is 38, the lowest value is 10, the number of classes is 6. We go to the next, proceed with this step. This will be 28 divided by 6. And as you know, 6 goes into this by 24 for 4 times. Then we are left with 24, where with a 4 add a 0, you can do it on the calculator. We shall be having 4.66 recurring. And remember, we said if any class interval must be a whole number. So we shall round off, and we have 5. So our number of classes that we're going to use, the class interval is 5. So having looked at that, and we've already determined that we're going to have the class interval is 5. Remember, the lowest, now we go to preparing the frequency table. The lowest is 10, and we know in between here we have 5. So, but we're not going to go. So where are we going to go? We're going to go to 14. I'm here to explain why from 10 to 14 instead of 15. I'm here to explain when we talk about the class boundaries. Then what is the next from here? We have 15 to 19. Are we following? Next we have 20 to 24. Next we have 25 to 29. Next we have 30 to 34. Next we have 35 to 39. Now here we have our classes. Remember, we have used this 5 to give us the gap. I'm yet to explain from 10 to 14. You may say it is 4, but I will explain how the 5 comes to that. Now, we have all this information. And if we are to tally, you can be in a position, we shall begin the tally. 23, where does it fall? We shall have to come, it falls in here. We keep on tallying. Where is the 24 going to fall? We shall come to where 24 is, still in the same row. We keep on tallying. The tally continues. All this is done. We keep on tallying until we... So students, we have now done all the tally and we have come up with this. You know that frequency is all about counting your tallies. You can see this, a bundle is 5 plus 3. This is 8 for the class of 10 to 14. This one, 1, 2, 3, 4, 5, which comes to 28. This one, as you can see, it comes to 27. It is 1, 2, 3, 4, 5 plus 2. This one we have 12. This one we have 4. This one we have 1. And we come up with summation of frequency. So this plus this is 5, 17. 17 plus 27. Of course, we can first do with the calculator. You don't need to bother. 28 plus 27, this is 55. 63 plus 12, we come to 75, and the total comes to 80. So as you can see, we have already done our simple example where they required us to prepare to group the following raw data in 6 classes and form a frequency table. This is the frequency table, and you'll be in position to understand how to do it. Now, for our next, we want to look at class limits and class boundaries.